So for this first review, let's take a look at what we're doing. So to find an equation that gives the nth term of each sequence, instead of the initial value of the kth term in your sequence, use the k given. So what is happening in this one? Well, it looks like it's going down or up 20. So we could say our term, so a sub n, I want to use the second one, so 136 plus 20 times n minus 2. Because once again, if this is our term, it has to match that term value. So k equals 1. Well, what is our ratio here? Again, to find any ratio, take a term divided by the term before. So we keep the top one times, we flip the bottom one. So this would be 2 over 6 or 1 over 3. And I'm going to check to see if that's the same. So what's 2/9 divided by 2/3? So that would be 2/9 times 3 over 2. So 3 over 9 or 1/3. So our ratio is 1/3. And we need to use our first term. Okay, so g sub n, I'll use, since it's geometric, 2 times 1/3 to the n minus 1. Because again, that first term, so I have my 2 and my 1. For the sequence 8, 5, 2, what is the 315th term? Well, I'm looking at this and I'm saying it's arithmetic. So a sub n, if I use the first term, 8 minus 3 times n minus 1. Okay, well, I need to find the 315th. So the 315th term is 8 minus 3 times 315 minus 1. And you would have your calculator for this, so negative 934. Could they represent, so here's some points, could they represent linear, exponential, or neither? So again, I always have to see it this way. 4, 11, 5, 16. Plus 5 plus 5, so this one would be linear. Let's see, negative 10, 3, negative 9, 6, negative 8, 12. Well, this is times 2, so it is exponential. Is it linear or exponential? Justify which way? So, okay. Well, what's our input? Well, I notice here it's going up by 5. Here it's going up by 3. So this would be linear. Because equal, what is that equal valid? Inputs, trying to think, let's just say our inputs are going up by 5. So when inputs go up by 5, outputs are changing by 3. So is it linear or exponential? And identify the slope or ratio. Well, this is exponential, and our ratio would be 3/5. Where this one's linear, and if I distribute 6x minus 24, so y minus 7, so our slope is 6. And on to the next page. It is known that an exponential function passes through the coordinates 3, 6, and we don't know 4, 5, 6, 7, 8, and 9 is 42. Write an equation for this. Okay, well, let's see. Times are, so if I start at 6, 1, 2, 3, 4, 5, 6, times r 6 times, and I get 42. So divide by 6, divide by 6, r to the 6 equals, I could reduce that down to 21 over 3. Which, if I'm thinking, 21 over 3 is 7. And then I could take the 6th root. So r equals the 6th root of 7. So an equation here, if I was to say f of x equals, let's see, if I start with 6 times the ratio, 6 root of 7, that would be x minus 3. Or if I started with 42 times that ratio, I'd have x minus 9. All right, the value 4 times 4 times 4 times 6 is an output value of that function. Write a function. So I start at 6 times 4 to the x power, and in this case, our x would be 3. Identify exponential growth or decay. Okay, so I'm going to say that this is decay because our b value is in between 0 or 1. So 8 times 1.7 to the x. So I know it starts at 8 and then it's increasing. So this one would be increasing. Is the exponential function negative 6 to the x? So it starts at 6 and it's increasing, but it's also a reflection, right? So I know that it was up here, but it's that negative reflects it, so it's down here. So it's going to be concave down. Find the limit as x goes to negative infinity. So I know that this starts at 4 and it's concave down. So as it goes to negative infinity, it's going up, so it's going to positive infinity. Let f of x be a function of transformations. Let g of x be a transformation of f. For each problem, name the function transformation. So this one went f of x times 9. All right. Well, let's see. That's like 9 to the first. So as a common base, this is 9 to the x plus 1. So this moved it to the left 1. So this is now 2 to the x over 16. Well, I want common bases. So 2 to the x over 2 to the 4th. So that's 2 to the x minus 4. So that's to the right 4. And let's see, this is f of x to the negative 3. Okay, so this is 7 to the negative 3x. So it is a horizontal dilation of 1/3, and this is saying opposite x values. So opposite x values, which opposite x values, so here to here, which is a reflect over the y-axis. All right, in this one, so we have negative and then 7 to the x over 49. So that would be 7 to the x over 7 squared. So negative 7 to the x minus 2. So I know that this is going to go to the right 2. And it's outside the negative, so that's opposite y value, which reflects over the x-axis. All right, so these are the ones where we just had to simplify this. So h of 2, so 6 times 4 to the 2/3. So 6 times the cubed root of 4 squared, which would be 6 times the cubed root of 16. And then when it's negative 1, so 9 times 2 to the negative 1 over 5. So that'd be 9 to the 2 to the 1/5. So 9 over the 5th root of 2. Okay, and this is the one where we had to write it in shifted form. So if we remember our steps, I'm going to see what it's going up by. So going up by 12, going up by 48, and that is going up by 192. So our ratio is 4, so that means our b value is 4. So if I was to write two equations here, I could take this one and say 3 equals a times 4 to the 0 plus k. Well, that's 1, so 3 equals a plus k. And then if I was to write another equation, 6 equals a times 4 to the first plus k. So 6 equals 4a plus k. And then this is where we had to solve this system. So I could rewrite this one over here, minus a, 3 minus a equals k. And then I could plug that in. So 6 equals 4a plus 3 minus a. So 6 equals 3a plus 3. And solving this, I can find that a equals 1. Well, if a equals 1, then I go back here. So 3 minus 1 equals k, so k equals 2. So that final equation, f of x equals a is 1 times 4 to the x plus 2. All right, number 22. The table gives the value of catfish selected. So use an exponential regression. And I'm just going to write the answers here. If you need to know how to go through the exponential regression, please make sure you refer back to those calculator help videos. So your exponential regression should be about 0.078 times 1.288 to the x. How will it weigh after 5 weeks? So we'll plug in 5. And again, for both of these, you could use on the VARS key, right? On the TI Inspires. So this one should be about 0.275. This one's 0.457. When will the catfish weigh 1 pound? So again, you could graph this, because you could graph your f of t, and your y1, and then you could graph, because you want to know when does 1 equal 0.078 times 1.288 to the x. So again, if you graph each part of those and find the intersection, it's at 10 weeks. This would be a great example of an extra credit on there, because this is dealing with 2.6 and finding the error. So again, if you want to know how to find the error, it turns out to be 0.01, but go ahead and watch the extra credit of 2.6 for this one. And then the same thing for this one. This is at 2.6. This would be example of extra credit. And so their predicted value would be, it's an overestimate, because it was 0.591 and the actual is 0.501. So same thing for number 3. This is a great extra credit one, 2.6. Is the model appropriate? Why or why not? And I would say yes, because there's no clear pattern. This is also that extra credit for 2.6. And again, I'm going to ask that you watch 2.6 to answer these. It is an overestimate of 0.6333. And what does point Q occur? Because it's above the x-axis, it is an underestimate of 0.3. All right, and then we have some composition of functions. So g of f of 4. So f of 4 is 2. So this is g of negative 2, which is 10. And this is f of g of 0. Well, g of 0 is negative 2. So f of negative 2 is 9. All right. So this next one, find f of g of negative 1. So g of negative 1, 5 minus 3 times negative 1. So that's 8. So then what is f of 8? 3 times 8 squared minus 4 times 8, which is 160. So g of f of 1. So f of 1, 3 times 1 squared minus 4 times 1. So 3 minus 4 is negative 1. So now we have g of negative 1. So 5 times 3 times negative 1 is 8. So you have to fill in the table. So h of x is f of g of x. So what is g of negative 5 is 2. So f of 2, 7 times 2 minus 5. So 14 minus 5 is 9. So our next one would be g of 0, which is negative 1. So f of negative 1, 7 times negative 1 minus 5 is negative 12. And then what is g of 5? Well, that's easy. That's 3. So now we do f of 3. 7 times 3 minus 5 is 16. All right, so find these values. So g of 1. So g of 1 is negative 2. So what is f of negative 2 is up here at 3. So the next one, g of negative 3 is right here. So what is f of negative 2? And that again is 3. And the last one, so f of 2 first is 1. So what is g of 1 is negative 2. All right, so find f of g of x. Okay, so I'm going to take f of 1 minus x. So this would be 1 over 1 minus x minus 6. So this is 1 over negative x minus 5. And then g of f of x. So g of 1 over x minus 6. So 1 minus 1 over x minus 6. What is the domain of f of g of x? So this part is all reals, so we're good there. But when we look at our function 1 over negative x minus 5, the denominator can't equal 0, right? Because we can't divide by 0. So x cannot be 5. So it would be all real numbers except x can't be 5, or negative 5. 5. Wait. Plus 5 plus 5. So it can't be negative 5. And state the domain of g of f of x. Right. So when I look at this inside domain of f of x, 1 over x minus 6, I know x can't be 6. And then when we look at our final one, it would be the same way. So our domain is all reals, because when we look up there, we still can't have 0 on the denominator, but x can't be 6. And then some composition. So write these as two simpler functions. Okay, well, I see the square root, so that's got to be our outside one. And then our inside would just be 7 minus x squared. Find the inverse and state the domain. So our inverse, okay, x equals y minus 2 squared plus 1. So x minus 1 equals y minus 2 squared. Square root it. So plus or minus the square root of x minus 1 equals y minus 2. And then we add 2. Okay, and then it says find the domain and range of the inverse. So our initial one, what is our domain? Well, we said x has to be less than or equal to 2. And our range, well, it moved up 1, so y has to be greater than or equal to 1. So our domain of this inverse, remember they switch. So our domain would be x is greater than or equal to 1. And our range would be y is less than or equal to 2. And hold on, we just have to switch this since it was plus or minus. We're just going to stick with the negative side there.